So the question is, for how many values of x is the function f of x equals limit n tending to infinity x to the power 2n minus 1 divided by x to the power 2n plus 1 discontinuous. So here you have to see that it's f of x, and the variable in the limit here is n. Yeah, n is tending to infinity, but the variable for the function f of x is x, not n. So let us first consider the argument itself, of the limit. That let us call it g of x, that is x to the power 2n minus 1 divided by x to the power 2n plus 1. We can easily see that it is an even function. If you replace x with minus x, we get the same expression. So whatever holds true for x must also hold true for minus x. Now the function x to the power 2n changes its behavior when mod x is equal to 1. That is when x is equal to plus or minus 1. When x is just less than 1 or just greater than minus 1. So when mod x is just less than 1, if we take the limit now of x to the power 2n as n tends to infinity, you're multiplying something that's just less than 1 by itself, many times, and so that will then tend to 0. Now if it's you take the other side of the limit, so limit x tending to 1 plus, and you now start multiplying a number that's slightly greater than 1 by itself many times, that will tend to infinity. And so when you take its reciprocal, x to the power minus 2n, that limit will tend to 0. Okay? And so now we consider the original function f of x, and we find out what its limit is when mod x is tending to 1 minus. When we do that, we can apply what we found out in this previous step. So x to the power 2n, that limit is 0. X to the power 2n in the denominator also will have the same limit. So it becomes 0 minus 1 divided by 0 plus 1, which is minus 1. Now if you take the other limit, limit mod x tending to 1 plus of f of x, what you get is this expression here, and then we take x to the power 2n common in both the numerator and the denominator. So you'll get in the numerator x to the power 2n multiplied by 1 minus x to the power minus 2n. In the denominator, taking x to the power 2n common, you get x to the power 2n into 1 plus x to the power minus 2n. Now we can cancel the x to the power 2n in the numerator and denominator to get this expression in the next step. And now we can apply the limit. We are knowing that x to the power minus 2n is tending to 0. So that gives us 1 minus 0 divided by 1 plus 0, which is 1. And so we can see that the left hand limit is not equal to the right hand limit for both the points 1 and minus 1. And so f of x is discontinuous at both those points.